All students are welcome to next chemistry lecture of solid state. Dear students, in previous lecture of solid state we see just introduction for solid state by comparing the properties of solid, liquid and gaseous state. Then next one, types of solids. First one, crystalline solids, and second, amorphous solids. Next point, isomorphism and polymorphism. Now today we are here going to discuss about the classification of crystalline solids, or how crystalline solids are classified. They are just classified into four types, and today in this lecture we see the two types of these crystalline solids in details. So just take a review about previous lecture. So first one, solid state. Here the molecules are held together strongly with a strong force of attraction, and so they have definite shape and volume. Also their particles are, it may be atoms, ions or constituent particles, atoms, ions or molecules. So types of solids, there are two types of solids, main two types. First one, crystalline solids. The properties of crystalline solids are, first one, there is a regularity and periodicity in the arrangement of constituent particles in crystalline solids. Here the order of arrangement is in a long range. Now second one, crystalline solids have sharp melting points, that they have a fixed or definite shape and volume, so they have a sharp melting point, that they melt at a definite temperature. Now next one, this shows a property of anisotropy. What is anisotropy or anisotropic substances? It is here cubic structure is exception for this one. Here there are some properties like refractive index, thermal and electrical conductivity. If we measure these all properties in different direction, the values are different. So this is the property of anisotropy, which is shown by crystalline solids. For example, ice, salt, NaCl, metals, sodium, gold, copper, etc. This is the first one, crystalline solids. Now students, next point, amorphous solids. Particularly here the arrangement is in a short range. So they are, or their particles are arranged in randomly arranged particle structure. Second one, they do not have a sharp melting point because a short range of arrangement of constituent particles. They just melt over a temperature interval. And next property, just on heating, amorphous solids continuously become soft and starts to flow, so they are also called as super cooled liquids. And next property, these solids or amorphous solids are show isotropic property, or they are isotropic. What is isotropic property? If we measure different properties in different direction, the magnitude of these properties are same in any direction. In opposite to anisotropy, amorphous substances shows the property like isotropy, or these solids are isotropic. Example, glass, plastic, rubber, etc. So students, these are two main important types of solids. First one, crystalline solids and its properties. Second one, amorphous solids and its properties. Next one, isomorphism and polymorphism. So what is isomorphism? Here, if two or more substances having the same crystal structure are said to be isomorphism. Substances are different. For example, sodium chloride, NaF and MgO, magnesium oxide. Their composition or elements are different, but the crystal structure is same, so they are termed as isomorphism. Here one other thing is same in between these two, as they has same atomic ratio, that is NaF 1:1, sodium 1 atom, chlorine 1 atom, same MgO, Mg2O, it is 1:1. This is the second property, same atomic ratio. Another example, NaNO3 and CaCO3. Now student, next one, polymorphism. What is polymorphism? A single substance that exists in two or more forms or crystalline structures. They are said to be molymorphous. The most familiar example is of carbon. The carbon present in three forms. First one is diamond, second one graphite, and third one Ferrari. This is the another example of quartz. Also calcium carbonates. They are different structures, so they are said to be polymorphous, or they shows polymorphism property. This is the just overlook of the previous unit. Now students, we are move towards the next point, classification of crystalline solids. As we seen in previous lecture, the crystalline solids have their arrangement of particles are in a long range. They have fixed up, so they have a definite shape, and depending on that, or particularly how the constituent particles, it may be atoms, ions, or molecules, held together to form a particular structure or having a definite shape. These crystalline solids are classified into four main groups. First one, ionic crystal, second covalent network crystal, third one molecular crystals or solids, and fourth one metallic solids or crystals. So examples of this one, first one, ionic crystals or solids are NaCl or KCl, sodium chloride or potassium chloride. Of covalent structure, maybe diamond, quartz, boron nitride, etc. Of third one, molecular crystals, it may be chlorine, methane, hydrogen, etc. Molecular crystals. That is on solidification. This substance on solidification gives molecular structures. And last one, metallic crystals, particularly metals such as sodium, potassium, calcium, iron, silver, gold, etc. These are the examples of these solids or crystals. Now students, in this lecture we just collected information about two main types. First one, ionic crystal, second one, covalent network crystal. Just we see what are the properties of ionic crystals, examples, also properties of covalent network crystals, and also examples in details. So starting with first one, ionic crystals. What are the properties of ionic crystals? Yes, the first property, the constituent particles of ionic crystals are charged ions, and the cations and the anions may be differ in size. This is the first property, they are charged ions. Particularly, for example, we take NaCl, sodium chloride. It exists in form Na plus and Cl minus. Na plus, here cation, that is positively charged ion. Anion, Cl minus, and they are just held together of strong electrostatic force of attraction. How it is, we see in detail in second point. So their constituent particles are charged ions. This is the first property. Second, each ion of given sign of charge is bonded to ions of opposite charge around it by Coulomb force. That is Coulomb force. It is also termed as electrostatic force of attraction. In other words, Particles of ionic crystals are held by electrostatic force of attraction between oppositely charged ions. What is the electrostatic force? It is of two types: electrostatic force of attraction, and second one, electrostatic force of repulsion. Here, force of attraction between oppositely charged ions, that is cations, positively charged anions, negatively charged. If you take two cations, that is there is two positive charged ions, that are cations, then there is a electrostatic force of repulsion, that is same atom or same charges repels to each other and opposite charges attracts with each other. So in this ionic crystals, these charged ions or simply cations and anions are held together by a strong electrostatic force of attraction. That is, it is present between oppositely charged ions. Now, third property, ionic crystals are hard and brittle and they have high melting points. First one, they are hard in nature, and second one, brittle property. If we apply the stress on this one, just they change their structure or deforms before rupturing. That before breakdown of this ionic crystals, they just deform their structure or goes into different structures. So, and this property is termed as brittle one or brittleness. And they have high melting points because of their structure is have a definite shape due to a long range of arrangement of their constituent particles, particularly ions. And so therefore they have a long range of arrangement of their particles and so have high melting point. Now students, last one, they are non-conductors of electricity in solid state, particularly when they are present in solid state. They are non-conductors of electricity. However, but when they melted or dissolved, comes in dissolved state or dissolved in water, particularly when we take example of NaCl or KCl, if you dissolve in water, it carries the current or there is a flow of electricity in given solution of particularly ionic compound. Or if we take the melted solution, then there is also flow of electricity there. They are good conductors in melted and in dissolved state and non-conductors in their original or solid state. So students, these are the properties of ionic crystals. Particularly first one, the constituent particle charge ions. Second one, they are held together by strong electrostatic force of attraction. They have hard one. Second one, they show brittleness. Next one, they have a higher or high melting point. And next one, about electricity, they are non-conductors of electricity in their solid state and in melted or dissolved state they become a good conductor of electricity. Examples: sodium chloride, potassium sulfate, K2SO4, calcium chloride, potassium chloride are the examples of simply ionic crystals. Now students, we move towards the next point, covalent network crystals. The properties. First one, here the constituent particles in covalent solids are atoms. We seen in previous lecture that the crystalline solids have the particles which are referred as, it may be ions, it may be atoms, or it may be molecules. Here in ionic crystal we see the constituent particles are charged ions, but in covalent network crystals the constituent particles are atoms. Again, the atoms in these crystals are linked by a continuous system of covalent bonds. So how covalent bonds are formed? Covalent bonds are formed by simply sharing of electron pair in between two atoms, two different atoms, or same atoms. So this result in rigid 3D network that forms a giant molecule. That is, here in the entire crystal is a single molecule. Third property, as a high rigidity and strongly bonded structure, this covalent are very hard one. As in second property we see, this is due to rigidity they form a continuous system or 3D system of covalent network, and due to it acquire a rigidity and strongness, and therefore they become very hard. Example is a diamond. Next one, they are incompressible, that are not easily compressed. All these materials are incompressible one, and due to this hardness, high hardness and 3D covalent structure, they have high melting and also boiling point. Now next property, the electrons are localized in covalent bonds and hence are not mobile. Localized in a fixed position, they are placed in a fixed position and hence are not mobile. As a result are, so these covalent solids or say crystals are poor conductors of heat and electricity. So simply examples are diamond quartz, that is silica SiO2, is one of the form of silica. Boron nitride, carbonandum, all these are the examples of this covalent network crystals. Students, you just read the brackets or information in bracket, given in bracket also. First one, do you know, try this, can you recall, remember, all this information is so important for your related points. That is, first one, diamond is the hardest known material, is containing the related to covalent network crystal. Also try this, graphite is a covalent solid yet soft and good conductor of electricity. Explain. You just find out it on internet. All these points are, the questions are just find on internet. So students, today in this lecture we just see next point on solid status. There is classification of crystalline solids. There are, first we see what are the main important types of crystalline solids, that are ionic crystals, covalent crystals, molecular crystals and metallic crystal, and example of these one. Next, details about ionic crystals. There is property, first one charged ions, second one electrostatic force of attraction, third one hardness and brittleness, next melting, higher melting point, next conductivity of electricity. There is a non-conductors of electricity in solid state and they have become good conductors in melted or dissolved state, and examples. Now next one, covalent structure. Particular constituent particles are here atoms. They are strongly held by a covalent bond which is formed by sharing of electron pairs between two different atoms and give a 3D network structure. Due to it obtain a rigidity or hardness, and therefore they are incompressible and also have higher melting and boiling points. And last one, due to localization of electrons or fixed position in covalent structure, they are poor conductors of heat and electricity. And simple example, diamond, quartz, boron nitride, carbonandum are covalent network solids. So this is the second point. Next, students, in next lecture we see the Next one, molecular crystals and metallic crystals.